Before we get started, to find out how a PIR works, please have a look at my How It Works video. It's explained and illustrated in such a way that anyone can understand it. I go through what PIRs can actually see, the importance of the lens, pulse counting, false alarm immunity, and much more. A link to the video is above and also shown at the end of this video.
The Racal 1012 PIR. I believe these were made in Scotland. Used to fit loads of these when I first started work when I was 15 years old, and these were sort of like the top range detectors that you could buy. I remember them being about £40 to buy, which is quite expensive. So there's two different versions of these. There's this one with a, I'm not sure, what is it? 1012. So this is the one that Logan sent me, PIR with multi-zone lens on it. This one is a Racal 1025, even though that says 12 meters. These detectors are actually very easy to replace, because if you have one of these go 40, you just unclipped it from its back plate, remove both the connectors, and then plug the connector back into the new one. You've got 12 volts positive and negative. You've got the relay, which is normally closed when the detector has power and there's no movement. LF latch freeze. In the early days of control panels, if you had multiple PIRs, you might run out of zones on the control panel. So in other words, if you had like one of these on the landing, one of these in a bedroom, and you didn't have a spare zone, then you could put them both on the same zone, and you would then have this latch freeze wired up. And if that received, I'm not sure what it is, either a positive or a negative, then it received that when the system was set. And if one of these detectors picked up motion when the system was set, then it latched the LED for the PIR that actually caused the activation. So you can get away with putting multiple detectors on one zone, and then you would have to then go around the room when the PIR activated. Let's say this was zone 5 and this was zone 5. If there was a zone 5 activation, you go upstairs. If one of these LEDs was continuously lit, then that was the one that caused the alarm. There's also a T terminal there, I'm not sure what that does. MS is micro switch. Every single detector has a micro switch, which is like a tamper. So for this particular detector, it was on the back here. Just going to do the power and the normally closed. Now, my normally closed terminals activate an LED here. There we go. So when that LED is lit, then there is no alarm. If I activate it, and it might still be stabilizing at the moment. Yep, it is. Let's look at the lid. Now the lid is very, very flimsy. I'm not sure what material that is, but it's very thin plastic. I've seen loads of these that are being pierced by something, or maybe someone just reached up to it and put their finger through it. Is there really to seal the whole unit? I mean, you don't want sort of like areas and holes in this so that things like spiders can crawl in. These are the fixing holes, so normally they will be used to screw it to the wall, or if you're mounting it on the corner, then it'll be on the side here to mount it onto a corner. But then you had these holes here. Now these were, I'm not sure what these were actually for. Maybe it's for a cable tie, so that inside you can then put a cable tie out and then back in again and then zip the cables up, but I don't know. But I mean, that just creates a hole for animals and things to fall inside. Right, that's now powered up. What we're going to do now is we're just going to observe it working. So the green LED indicates the relay is in a normal condition, which is normally closed, and there is no motion. Now you will notice that the detector, and this was a common thing with some of these Racal detectors, especially the 1012, there was a Scorpio, and also there's an Apollo. If it's not quite sure, then the LED will come on the first time, but the alarm relay will not operate. So let's just try and move very, very slightly now. There you go. So that was the first pulse, no alarm relay. There you go. Second one, off goes the alarm relay. So now it's detected motion for the first time. It's now assuming that everything else it sees is motion. But if we just let it time out again, first pulse. So that could be a potential false alarm that's just ignored. Really wasn't quite sure then. I'm actually triggering the little lens that's in the middle there. Now the reason for that lens being moved up into that position is it moves it in line with an LED which shines through where the pyroelectric detector would be if it was downwards. So that is the pyroelectric detector. That's what's actually looking at the lens, that's doing all the work. And then the LED above it, you see that it's not lit, and it's not a walk test LED. It's not like this one here, shows you when there's motion. This one is selectable, and it's selectable by, I think, this link here. Oh no, that's the LED on-off link, so it must be one of these. It's this one here. So what I need to do is I need to find a link and put it over these two terminals here. Link 3, and then there's a link 2. Now link 1 is a bit strange because there's the LED, and you would have thought that this little link here will be the one that turns off the LED next to it. But it doesn't. I don't know what this does, but I think this is something to do with the latch freeze function, which I explained a bit earlier. But really you need the instruction manual to work out what these do. Jumper 1 to start with, and what this does is it actually short circuits the walk test LED. It's a bit weird that. Normally you would take a link out to disconnect the circuit so it doesn't light up, but this one actually places a short across it. It's really weird. I mean, obviously the detector is still working, it's just some people don't want the light to come on. I'm going to leave that on, but instead I'm going to place it on link 3, and that activates that LED in the middle there. The only purpose of this LED in the middle is for alignment. And what happens is, you can see it's like shining through these different grid areas. That's what it's for, but you have to put it in the right position. Now you can see where the screws used to be, and if this was down, then the lens would line up with the pyroelectric detector. But when you shifted the whole lens up a little bit, then the lens aligns with the LED here instead of this. So the idea is you don't leave it in this position, it's just so that you can see where all of the detection zones are, and you can sort of like walk around the room and go, oh, that's where one will detect motion. Then if we go down a bit, that's the lower segments there. Then you've got the ones that look down here, and then underneath, where's the detection? There it is.
thanks to Logan for sending me the IR1012, plus lots of other stuff that I hope to show in a future video. Please visit his YouTube channel, a link is in the description and above.
Energy circuit. 29 key is long. Should I just zoom?
Watch as the heat source moves across the detection zone of the lens. One element receives a reading slightly ahead of the other, creating two readings per segment of the lens. Positive and a negative needs to be generated before a pulse is recognized. A lot of time and effort goes into creating these videos to make them as interesting and informative as possible. Our motto is quality, not quantity. If you've enjoyed watching, please consider subscribing to the Mr. Matt and Mr. Che channel.